this experiment, we will be using a 20% stock solution in water to determine the concentration of a new diluted solution. First, we obtained a sample of the 20% stock solution. Using the pipette, we extract the solution and record the transfer quantity unit using the meniscus, which is the curved surface that forms at the top of a liquid inside a container when it meets the walls of the container. This curvature occurs due to the adhesive and cohesive properties of the liquid molecules as well as gravity acting on the liquid. In the image shown, the recorded amount should be less than 20 because that is where the bottom of the curve is. After finding the initial mass of the beaker, we recorded the mass of both the solution and the beaker to find the mass of the solution, which we used the equation final mass minus initial mass. By taking the newly acquired mass of the solution and the volume that is displayed in the beaker, we were able to find the density of the solution to be roughly 1. Next, we had to record data to establish a relationship between concentration of sugar in aqueous solutions with the solution's density. We did this by taking the concentration and density of a solution and finding out the density and concentration of the solution after adding water with no sugar concentration. To figure out the new concentration percentages, we had to find the new volume of the solution after the water was added. Using the equation C1 times V1 is equal to C2 times V2, we were able to multiply the initial concentration percentage, which was 20%, by the initial volume before the water was added. Then, by dividing the final volume by this number, we were able to figure out the new concentration. Next, we had to find the density of the new solutions. We found the mass of the solution, which we got by subtracting the overall mass of both the beaker and the solution by only the mass of the beaker. To determine the density, we took this newly acquired mass and divided it by the new volume of the solution. All of these calculations are shown in the following image. We were able to graph our data by having the x-axis represent density and the y-axis represent the concentration percentage. After inputting the data points, we were able to create the calibration curve for the sugar solution and find both the calibration equation and r-squared value. Finally, we had to find the concentration percentage of the mystery solution. We were able to find this by finding the volume of the solution by recording the number at the meniscus of the solution in the pipette. Then, we had to find the mass of the solution. By dividing the mass by the volume we recorded, we were able to find the overall density of the solution. Finally, by plugging the density into the calibration equation found earlier, we were able to compute the overall sugar concentration in the mystery solution to be approximately 13%. This calculation is shown in the following image.